All right, today we're diving into a really cool story from the world of economics. It's got everything: a brilliant shortcut that was supposed to change the game, a tiny mistake hiding in plain sight, and a great example of how science fixes itself. We're talking about large Bayesian VARs.
So, let's just start with a huge question. How in the world do you forecast an entire economy? I mean, everything. Inflation, jobs, growth, all of it, all at the same time. It sounds kind of impossible, doesn't it?
Well, for decades, economists have known that to even have a shot at getting it right, their models need two crucial ingredients. First, you need more data. A lot more data. The more variables you can track, the clearer the picture. And second, you need more realism. You have to accept that economies aren't nice and stable. They have calm periods and then they have really chaotic ones. Your model has to be able to handle that volatility.
But here's the catch. For the longest time, trying to have both more data and more realism created this impossible trade-off. It was a massive computational headache, basically a giant scaling problem.
Here was the dilemma, right? On one hand, you want to add more variables, things like industrial production or housing prices, because that makes your model smarter. But on the other hand, every single variable you add doesn't just add a little more work, it makes the number of calculations you have to do explode, like exponentially.
And this number right here, this is the monster they were dealing with. The problem had a computational complexity of order n to the sixth. So what does that even mean? It means if your model has, say, 10 variables, and you decide to double it to 20, the calculation doesn't get twice as hard, it could get up to 64 times harder. This was the computational wall that just kept these bigger, more realistic models from ever being practical.
And that's what sets the stage for the first big moment in our story: a really clever solution that came out in 2019.
So, in the Journal of Econometrics, these three researchers, Carriero, Clark, and Marcellino, they publish a paper with this brilliant shortcut. They figured out a totally new way to solve these huge models that just sidestep that computational explosion.
Their approach was called triangularization, and you can kind of think of it like solving a really complex jigsaw puzzle. Instead of trying to jam all the pieces together at once, you do it sequentially. You solve for the first variable in your system. Then you take that answer, you plug it into the next equation, which makes that one easier to solve. And you just keep going, one by one, letting each answer help you solve the next until the whole thing is done.
And the result? I mean, this was a total game changer. For a pretty standard 20-variable model, their new method was up to 400 times faster. It took that terrifying n to the sixth complexity and knocked it down to n to the fourth. All of a sudden, building these massive, realistic models of the economy was actually possible.
It was a huge leap forward. And you probably knew there was a but coming. As it turns out, there was a twist, a hidden flaw that nobody noticed for a few years.
And you don't have to take my word for it. In a 2022 correction, the authors themselves put it very clearly. The original algorithm had a mistake. It was missing a critical piece of information.
So what was the flaw? Well, to put it simply, the algorithm was only looking backwards. As it was solving, say, equation number 5, it was using all the information from equations 1, 2, 3, and 4. That part was fine, but it was totally ignoring the information from equations 6, 7, 8, and all the others that came after it. It was like trying to solve that puzzle, but only looking at the pieces you've already put together, not the ones still on the table.
But this is where the story gets really good, because this wasn't the end. It was a chance to make the tool even better. So let's look at how they fixed it.
So in 2022, the original team, now with another researcher named Joshua Chan, published what's known as a corrigendum. It's basically academic speak for, hey, we found a mistake, and here's the fix. They were totally open about the problem, and, more importantly, they solved it.
And this slide really gets to the heart of the fix. The old algorithm was like a one-way street. The new corrected algorithm is more like a round-table discussion. It uses a clever technique called a Gibbs sampler, which basically cycles through all the equations over and over again, constantly updating its estimates. This makes sure that when it solves for any one part of the model, it's using information from every other part of the model.
And here is the absolute best part. That critical breakthrough, the massive speed advantage, they kept it. The new correct algorithm is still n to the fourth. They managed to fix the mistake without losing the magic that made it so revolutionary in the first place.
Okay, so we've gone through this whole story about algorithms and mistakes and fixes. But why does any of this actually matter? Well, because at the end of the day, it gives economists a much sharper, more reliable tool to understand our world.
The results really speak for themselves, and this was the key finding from the original paper that still holds true. Look, small models do okay. Big models that don't account for volatility do a little better. But the real sweet spot? It's the large models that use lots of data and account for that messy real-world volatility. That's how you get the best forecasts.
So having this fixed, fast tool unlocks some really important stuff. It means more accurate forecasting for businesses and central banks trying to make big decisions. It lets us get a much better idea of how a big policy change, like an interest rate hike, is actually going to ripple through the whole economy. And it just opens the door to building even bigger and more realistic models than we ever thought possible.
You know, when you take a step back, this is more than just a story about economics. It's a fantastic story about how science is supposed to work. You discover something new, you share it with the world, you let people kick the tires, and if someone finds a flaw, you work together to fix it and make it better. It's all about progress, not pretending to be perfect.
Which really leaves us with one last, and pretty exciting question. For so many years, the sheer complexity of the economy limited the kinds of questions we could even try to answer. But now that this incredible tool has been built, tested, and corrected, what are the big economic mysteries we can finally start to unravel?